Okay, so yeah, right. Good evening to again. Yeah, today we are going to discuss the equations of motion. So, what are the equations of motion? What is the importance of actually equation of motion? Okay. Uh, so give me 1 second. Let me keep it on the right. Right. So, so what is the mechanics? Why we need to study? So, whenever you start a new lesson in any subject, first thing you guys need to ask what is actually. It could be chemistry, it could be maths, it could be physics, anything. First, we need to
Yes,
know
sir.
the topic, mechanics. So, the mechanics is the branch of physics which deals with the totally it's related to the mechanical system. Like what is a mechanical system? Like a body is moving, like a body is freely falling, a body you're throwing object upward, like lawn roll, a lot of day to day activities. The topics which involve completely mechanical energy related stuff. So mechanics is the one of the main branch of the physics, which always deals with the equations of motion, which always related to the motion of the object. It could be freely falling bodies, it could be vertically projected upward, or it could be planar motion, straight line motion, Newton laws, everything. All these topics comes under the mechanics. So when I want to, the basics of the mechanics to understand, so we need to begin with the equations of motions. So what are the equations of motion? I mean, what are these? What are these physical parameters are involving in this equation of motion? Especially, you need to understand here what are the U, V, A, S. All this terminology you should able to understand. So
Yes,
when
sir.
I
Yes, sir.
say here equation of motion, when a when an object to be in a motion, what we need, the first thing you need to know whether object started with initial velocity, right? So U
Yes,
is
sir.
the initial velocity. Okay. Then when an object started, it definitely, it has acceleration, right? So acceleration is the rate of change of velocity. If the velocity changes with respect to time, the object has acceleration. Okay. Then whenever the object is moving with respect to time, definitely the time is also involving. And when it's object moving with respect to time, it started from a point and ending at B point. The velocity of the object at initial point is called initial velocity. The velocity of the object at final point is called final velocity. So V is the final velocity. Okay. So, I mean, whenever the object moves from A to B, it travel the displacement S, right? Or distance. Sometimes we call it distance, sometimes we call it displacement. Depends upon the situation. When you call the displacement, you should write it. A displacement is a vector quantity. Distance is a scalar quantity. Okay. So these four equations are basically involving these four parameters. Okay. So, but question, when I have to use these equations, sir? I don't know. Like, yes, do I need to buy hard it? No. When should I use it? So we are going to discuss it. It depends upon the situation. So if the body, if the given problem, if the given situation mention only initial final velocity, acceleration time, you have to use this equation. Suppose if they ask you to calculate distance or displacement, with a given of initial velocity, acceleration time, you have to use this equation. If they did not mention the time, if they mention only initial and final velocities, acceleration, distance, you have to use this. So among these four parameters, sometimes they give three, they'll ask the fourth parameter. Okay. So this is the nth second. Sometimes like you, if I ask you to calculate the velocity, initial velocity or distance, sorry, calculate the distance of the object at 10th second. Suppose you thrown a object upward. So you have to
Yes, sir.
calculate what is the distance at second, third second, fourth second, fifth second, 10th second. If you want to calculate distance by given time, you have to use the this equation. Okay.
Yes, sir. By given time.
So,
Okay, sir.
so moving to the next slide. Right.
Right. Sir,
So,
previous slide once show, sir.
sorry.
Previous slide once show, sir.
Yeah, sure. You want to copy the stuff.
Yes, sir.
I
Yes, sir.
mean, nothing is there. You can, yeah. When I was explaining itself, you should take that's, it's wasting of time sometimes.
Okay, sir. 1 minute, sir. I'll take screenshot, sir. Yes,
Oh, sorry.
yes, sir. Completed, sir.
No, I didn't. This is the one actually you are looking, right?
Yes, sir.
Then
Took,
moving to
sir.
the second one. Yeah. So this is the slide. I'm going to tell actually, I'm going to explain the equations how we got it, but there is a two situation, very important situation. You need to know the how the equations of motion modify into a different equation, like how they modify into a is equal to g, etc. Okay, so how they modify, like when I suppose there are two situations. The first situation I'm trying to explain here, freely falling bodies. What is the freely falling body? Suppose if I release an object, okay, so when I release an object with a certain height, okay,
Yes, sir.
so its
Sir,
initial
yes.
velocity is zero. Its initial velocity zero. So, but any freely falling body cases, a acceleration due to gravity, acceleration of the object must be equal to acceleration due to gravity. So these two conditions you have to remember. Whenever the object is freely falling towards the ground, so in this situation you are not giving any initial velocity for the object. Simply you should make it zero. Its initial velocity equal to zero. How about acceleration? We always consider the g as a positive quantity towards the ground. When you are throwing object upward, vertically upward, g should be negative. Okay? So g is actually acceleration due to gravity. So g is positive towards the ground whenever the objects are falling down. So when you are throwing object upward, opposite to the, I mean, basically you are not throwing the object towards the ground. You are throwing against opposite direction to the ground. In that case, you have to take the g as a negative quantity. So when I substitute these two conditions in the equation which we discussed in the previous slide, so these are the two conditions we are substituting. So V is equal to U plus AT. So in which U is 0, V is equal to U plus AT, U is 0, so A is equal to G. So this equation becomes V is equal to GT. Is it clear? Right. So in the second equation, The equation was S equal to ut plus of at square, right?
Yes, sir.
So here I have to substitute u is equal to 0. When I substitute u is equal to 0, the first term becomes 0. You left, so s is equal to half at square. So the equation is a is equal to what? G. So you have to substitute a is equal to g. So this equation becomes s equal to half gt square. So coming to the third equation which we have, v square minus u square is equal to 2as. So this is the equation of third equation of motion. Here we have to put the condition a is equal to g, u is equal to 0. So when I substitute u is equal to 0, this is going to be 0. So we left equation v square is equal to 2. A should be, we have to substitute g, 2gs. Okay, sometimes you people write like 2gh also, because it depends upon s becomes h height. Okay, so this is over, third equation is over. Similarly, the fourth equation also we have, Sn is equal to u plus n minus of g. So u equal to g, u equal to 0. So where this equation, final equation becomes Sn is equal to n minus half into g. So it was a actually, right? So we substituted a equal to g. So these are the modified equation when the situation freely falling bodies, like when the bodies are like released with the initial velocity 0, a acceleration of the object become a acceleration due to gravity, which is a positive. Okay, so is it clear for now?
Clear, sir.
Yeah, I'm going to clear it now. So these are the things you have to remember. So the first four equations you have to remember. The situation now we have discussed, freely falling bodies. You should remember these two conditions. These two things you have to substitute. Okay, mainly you have to remember these two. Then simple. If you remember those four equations, you just substitute it. You get these four equations. Okay.
Yes, sir.
I'm clearing this. Do you want a copy?
1 minute, sir. I'll just take a screenshot. Yes, sir.
Yes. So moving into the, so now, so what is here? What we are discussing now? Yeah. Here's another situation. So vertically projected upward. Oh, sorry. Your vertically projected upward case. What is the what we are trying to explain here is, suppose you are projected an object upward. You are throwing an object upward direction. Okay, you have the ball in your hand. You're just throwing upward direction. In this case, A becomes minus G, right? So because you are throwing an object away and against to the acceleration due to gravity. So gravity direction should be G positive towards the ground, but you are throwing away from the ground, right? So which is actually A is equal to minus G. And another condition is there is an initial velocity, right? Without initial velocity, we cannot throw an object upward, right? So definitely initial velocity should be there and A should be equal to minus G. So now, so, but now the condition is, when I substitute this A is equal to minus G, all above four equation becomes like this. V is equal to U minus GT. S is equal to ut minus half gt square. V square minus u square equal to minus 2gs. Sn equal to u minus n minus half into g. So you can ask me question like, so sir, V should be 0 when it reaches maximum height. But I'm not talking about that now. That is a special case. When you're dealing with the maximum height, so I'm not talking like, at this maximum point. I'm talking just, I'm writing equations vertically projected upward direction. That's it. If I ask you specifically, what is the velocity at maximum height? If I ask you what is the velocity here, v is equal to 0. If I specify only what is the velocity, final velocity of the object at maximum height, that means the point where it reaches maximum, it doesn't go behind that. At that point, we equal to 0. But these are the general equation. We are not discussing specific case. Okay? Is it clear?
Yes, sir.
I mean, just only you have to substitute this condition. Whatever the four equations were there, a is equal to minus g, you just need to substitute. Wherever g was there, a is there, you just need to replace with minus g. That's it. Okay? So
Okay, sir.
can I close it?
Yes, sir.
Right. So I'm going to discuss this later because you don't understand this specifically. I mean, I can explain this, but later on I can come back and explain this. What is the maximum height? What is the time of flight? What is the time of ascent, time of descent? So you don't understand this now. I'll let you explain later. So let me explain these equations of motion derivation. How do we, I mean, I'm not going to explain everything like very basic derivation, like simple, like very short. I mean, this is a, I mean, you need to understand how we got this equation. I'm not going to explain like what is a, what is v, what is u. Already we discussed that basic stuff. So very simple derivation. If you keep in your brain this one, you can able to write, like, you can able to remember this equation easily. How we got this v is equal to u plus at. So you already know the definition of acceleration, right? What is
Yes, sir.
acceleration? It is a
The
rate of
rate of change of
change of velocity,
velocity.
right? Right. So rate, what is the rate of change of velocity? Which means what is the change in velocity with respect to time? So you need to write what is the change in velocity, final velocity minus initial velocity. Change in velocity means final minus initial by time. From this equation, if you want to write for equation for v, so v minus u is equal to at. Can I write like this? From this equation, cross multiplied a into t is equal to v minus u. If I want to write equation for v, u plus at. Is it clear, Pranav?
Yes, sir.
Very simple. So from the definition of acceleration, we got the equation v is equal to u plus at. Okay, right?
Yes, sir.
So do you have any doubt here?
No, sir.
Okay. So now the coming into the second equation of motion. So how we got this second equation of motion? So for this, you must know about the average velocity. We already discussed average velocity, instantaneous velocity, right? So, I mean, average velocity is the velocity which is actually average of initial and final velocity, right? So v plus u by 2. So this is the simple equation for average velocity. Suppose you have the initial velocity, final velocity. If someone asks you average velocity, you just simply add by 2. Okay. So this is called average velocity. So if I want to calculate displacement, so displacement equal to, we know that velocity is equal to s by t, right? If I want to write displacement, v into t, right? So here we are taking the average velocity into time, okay? Average velocity into time. So what is my average velocity? I already got it here. V plus u by 2 into time t. Okay. But from equation of motion 1, v is equal to u plus a t. We already know this guy. So we already know that v is equal to u plus at. So wherever the v is there, you just need to substitute this. Okay. So v is equal to how much I have to write here? V is equal to u plus at plus u is there. Okay. Is it clear?
Yes, sir. Clear, sir.
If you don't understand, please let me know. You don't need to say every time clear. It just want,
Yes,
I
sir.
just want, if you don't understand, ask me, repeat. So but here average velocity, I think you understand. Displacement
Yes,
simply
sir.
velocity into time. So velocity, you are taking average velocity, right? So where the velocity, final velocity, I'm writing the v is equal to u plus at. When I substitute this here, u plus at plus u plus u 2u, right? S is equal to u plus u 2u, if I want to write, plus at, okay, into t by 2, right? So if I want to multiply with t, the next step becomes 2ut by 2ut by 2, okay, plus 2u a 2u a, okay, t square by 2, okay, 2 cancel, 2 cancel. Oh, no, something wrong. This one, when I substitute this, half at square, I have to get ut plus half at square. How can I get this one? Let me check it. Mm, here half at square, right? U plus u. Okay, let me write again. U is equal to 2u plus 80. 2u plus 80. Let me correct, Pranav, if I do any mistake, let me know. Just tell me. U plus u
Yes, sir.
2u plus 80 by 2 into t, right? So let me separate this. 2u, 2ut,
Yes, sir.
2ut by 2, okay, plus 2u, oh, no, 80 into t, 80 into t, 80 square by 2. So 2 cancel. So you got this, ut plus half at square, right? So ut plus half at square. Any doubts?
No, sir.
Simply I added u, 2u by 2, 2 cancel ut, we got it. Here 80 into t, 80 square by t by 2. Okay. So you should able to keep in brain. It's a very simple derivation. You must know the average velocity and you have to calculate the displacement equal to average velocity to time. There, wherever the final velocity was there, final velocity equal to v is equal to u plus at, you have to substitute it, then simplify. That's it. Very simple derivation. Okay. Moving into the next slide. Okay, can I go? Can I move?
Yes, sir.
Yes. So last equation. I mean, I'm not going to explain the last one, but yeah, you don't need that. So equation of motion 3. For this also, you need to know very basic definition you need to know. One is the first equation, V is equal to U plus AT. We already know that. From that, I wrote it as A is equal to V minus U by T. So we can write it AT is equal to V minus U. If you want to write it A, V minus U by T. So simply I got this A value. Then I also got the S from the previous equation. S is equal to average velocity into time. So average velocity v plus u by 2 into t, right? So this is also we already did last slide. So average velocity, which is equal to average displacement equal to average velocity into time, u plus v by 2 into t. So now what you do, you just multiply these two. A S. When you multiply AS, what happens? Left side AS, right? Left hand side, you just need to multiply these two equations. Let us say 1 and 2. You can think about this equation 1 and 2, multiply it. So when you multiply left hand side, what happens? A into S, AS. Right side, what are the quantities are there? V minus U by T from here. V plus U by 2 into T from this. Okay. So we got both. So now TT cancel. TT cancel. What are there? A plus B into A minus B. Right? What is the formula for A plus B into A minus B? A square minus Pranav.
Sir.
Yeah, this 2 goes here. 2AS.
Yes, sir.
Whatever 2 in the denominator, 2 goes this side, left side, 2AS. Okay.
Sir.
Right side it becomes A plus B into A minus B. A square minus B square. Okay.
Yes, sir.
Did you understand?
Yes, sir. Understand.
So from this, how do we, what you have to remember? Simply first equation of motion. From that, A is equal to V minus U by T. Second equation, S is equal to average velocity to time. I mean, when you multiply these two, you get the equation of third equation of motion. Very simple. I mean, why we need to multiply is like to get that equation. There is no, I think, mechanics behind that. It just our convenience. Sometimes we do calculations, to get some output. Like if you know the answer, you can go back to the what are the initial condition. Okay, I mean, there are many methods to prove this one. Not only this method, graphical method also there. So you can also derive those, but I think you don't need now.
Yes, sir.
Okay, right. So let me do some problems here. So let me do some problems, basic problems. So this is actually IIT 2008 law. I mean, this problem came. Okay, in 2008, they asked this problem. It's a very basic. This you have to use the equation of motion, first equation of motion. And when you see here, IJK. What are IJK? These are the unit vectors basically. Unit vector. So I is along x-axis, J is along y-axis, K is along z-axis. Don't tense about this. This is very basic stuff. So these are the unit vector. Unit vector is a vector which has a magnitude 1. That's it. So here they gave the initial velocity in terms of the vector format. They gave the value vector format 3i plus 4j. And acceleration also they gave in the vector format 0.4 I 0. Plus 0.3 j. So unit vector we represent with caps basically. And time t 10 seconds they give. So then they are asking final velocity. What is the final velocity of the object? So we already know that final velocity is equal to initial velocity plus at, right? So final velocity is equal to initial velocity. You have to substitute as it is. So 3i plus 4j plus a t how much? 10 seconds. A is in vector format. You have to keep in the bracket because a is in the vector format. So that into 10. So time is scalar, just you have to multiply, right? So now then next what I have to do, you have to multiply 10 with all these two quantities. So when I multiply next step, v is equal to 3, as is you have to copy this 3i plus 4j. Then this step will become 10 into 0.4, how much? 4 I. 10 into point 0.3, how much? Tell me. 3. This is 3 actually, sorry. This is 3j. Okay? Pranav.
Yes, sir.
V is equal to U plus A. U as is, I wrote it from the question. T10, A as is from the question. Then next step, what I am trying to do here, I am multiplying 10 with these two. 10 into point 0.4, how
Yes, sir.
much? 10 into point 0.4, how much? 4, 10, 4 only, right?
Yes, sir.
Point 0.3 into 4, how much? 3 only. So I just substituted 3i plus 4j plus 4i plus 3j. So when you have to add only ii. You cannot add I plus j. You cannot add I plus 3j. It's not possible. So vector addition, because I is along, so I is along x-axis, j is along y-axis. You cannot add,
Y-axis.
yes, you cannot add I with j. So you can add only I component along x-axis. So how many I components are there? 3i plus 4i. So 3i plus 4i, how much? 7i. You can add only I component separately. Then you can also add j component. 4j plus 3j, 7j. So like that you have to add when you are doing the additions in the vectors or subtractions. Simply add I component separately, j component separately, k component separately. You cannot add with 3i plus. Suppose if I ask you 3i plus 4j, you are not supposed to tell 7j, 7. Don't tell that. Don't tell the people. You have to tell 3i plus 4j. Okay.
Yes, sir. Yes, sir. Okay,
Someone
sir.
ask you I plus j how much? Don't tell that 2j 2i. It's just simply I
Yes,
plus
sir.
j only. Okay, it is a vector. It's a plane actually. The plane containing I and j. Okay. So I'm going to close this clearing.
Yes, sir. Okay,
Yeah,
sir.
I did not explain the last one. What is the magnitude of v? So magnitude I v. So as I mentioned, vector. What is a vector? Vector has a direction as well as magnitude, right? How do you calculate magnitude? Simply, you just need to square of this I component. I, what is the coefficient of I? 7. What is the coefficient of j? 7. Simply square root x component square plus y component square. I component square plus j component square. So 7 is there, I component. 7 7 is 49. Even j component 7 7 is 49. So that will be 49 plus 49. How much it is? 98, right? So
Yes,
98, I
sir.
can write it as a 7 root 2. Why? Because I can write 49 into 2. 49 into 2, 49 is 7. 7 root 2. Okay? So I'm going to clear it.
Okay, sir.
So did you understand last equation? What I'm trying to
Yes, sir.
do? Sure. So how do you write it? 7 square. I am writing here. So I component square 7 square 49. J component 7 49. There is no K component. I don't need to do it, right? How much
Yes,
it
sir.
is? 98, right? So I can write it as a 49 into 2. So 7 root 2. Okay. So why I'm writing? Suppose if I give I plus j, what is the magnitude? Tell me. Suppose I gave the vector as I plus j. If I ask you to calculate magnitude like this, you simply need to do 1 square plus 1 square. So root 2. Okay. Because I component is coefficient is 1, j component also 1. If I give the 2i plus j, that becomes here 4. 2 square is 4 plus 1, which is root 5. Okay, 2i plus j. So 4 plus 1 root 5. Is it clear?
Yes, sir.
Okay. Anyway, we are going to do vectors also. When we enter the motion in a plane, we are going to do a vectors. This is kind of tough maybe, but I will try it. So let me explain this. This is kind of a little tough, but I think you can able to do it. So that they gave the displacement as 2t square plus t plus 5, and they also mentioned t is equal to 2 seconds. What is the velocity? What is the acceleration? How do we calculate? So here I'm giving x as a displacement. So displacement is given. I'm defining x. X is, what is x here? Some kind of displacement. You can write any parameter, x, s, whatever, y, all are displacements. So I gave here s as a displacement, which is in terms of the time, and there is a constant 5 also. So how do we calculate velocity? Velocity definition is what? Rate of change of displacement. So rate of change of displacement means what? Delta x by delta t actually, right? But I am writing here dx by dt. What is the difference between the delta and d? Delta is a discrete case we use. Discrete means like changes should be like 1 second, 2 second, 3 second, like that. Discrete numbers. But when I use the d, continuous function, sometimes y is equal to x square. This is changing like continuously, like a parabola. There is no discrete values. It is changing, function is changing like continuously. So when the function changing continuously, you have to use the d. So this is a big difference actually. So dx by dt. So now you guys don't know the derivative. That's the biggest problem to explain now. So let me explain for this. How do you do? D by dt. Suppose if I keep any constant, 1, 2, etc., that's equal to 0. Why it's 0? Suppose if I keep the d by dt, so I am putting x value as 1 here. If I keep 1, it is going to be 0. Why 0, sir? Why? Because the 1, whatever I kept here, 1 is not changing with respect to time t. It is constant value, 1. Even if I keep 10 also, it is 0. Any constant, if you are doing the derivative, with respect to time, simply 0. Suppose if I keep here d by dt t,